Welcome! From this video, you will learn how to design CCTV systems with IP Video System Design Tool. By the end of this video tutorial, you will be familiar with features of the program and will learn how to use the IP Video System Design Tool for planning and designing efficient video surveillance systems. Let's begin. On the first tab, called Camera Installation Drawing, we can see a camera elevation view and a view from the top. You can change the camera installation height, distance from the camera to target, and field of view width by moving color endpoints with the mouse. Now let's look at the camera panel located in the upper left corner of the screen. As you can see, here you can change installation height by choosing the necessary value from the drop-down list or by typing the needed value into the installation height field. Also, you can specify here such parameters as camera sensor format, aspect ratio, lens focal length, and camera resolution in order to adapt the camera to your needs. You can notice that when you modify any camera parameters, for example, focal length, all the numbers in the top right corner also get changed. The program recalculates all the values automatically. Now let's look at the field of view panel located in the upper right corner of the program. There is a distance from camera where you can set the number of meters or feet from the camera to the target. You can use the height parameter to set the maximal height of the target. For example, at a distance equal to 20 meters, you want to see a man, which is 2 meters tall. Or you want to see a gate, which is 4 meters high. As you can see, changing field of view height affects the camera tilt. Using the next parameter, field of view width, you can make the field of view narrower or wider. The last parameter is height of lower boundary. You can specify the zone elevation starting from the floor up. Using this feature, you can cut out what you don't need to see. Beneath the field of view parameters, we have a camera 3D view window. The camera 3D window will show what the camera will see. Here we can see two test targets. These two 3D models of a man and a woman show a range of camera zone. The test man is located at the target distance. In the center of the main window, right beneath the camera, there is a blind spot or a dead zone. You can clearly see where the dead zone ends. The test woman is located at the end of the dead zone and at the beginning of the camera zone. In other words, the woman is located at the nearest point to the camera, and the man is at the farthest. You can tick checkboxes near the pictures of the man and the woman above, in the field of view, to display and hide these models. In the picture below the camera parameters, we can see the man's face with license plates. The quality of the photo is based on camera resolution and field of view width. If we divide the camera horizontal resolution by field of view width, also referred to as FOV width, we get pixel density. Pixel density is measured in pixels per meter, ppm, or pixels per foot, ppf. Pixel density is an established metric in the surveillance industry. The higher pixel density is the higher quality of the picture we get. With higher pixel density, we can distinguish smaller details. Pixel density for the specified target distance is shown in the status bar near the face of the test man. The pixel density for the dead zone distance is shown near the woman's face in the status bar. The pixel density will be different if we change the FOV width or camera resolution. How to minimize dead zones. Let's have a look at how to minimize dead zones. The first way to minimize dead zones is to use wider field of view or wider lens. Another way is to install a camera at the lower height. The third way is to decrease the height of the field of view. Thank you for watching. Subscribe to our channel and visit www.jvsg.com.